Hello, today I'm joined by Sven Veriken. He's the CEO and president of GPD Global, which is one of the more high technology dispensing companies in the industry. Welcome, Sven.
Thank you, Trev.
So, Sven, one of the technologies that you introduced last year and you're gaining a lot of recognition for is this placement valve that you have, which is not an auger, I believe.
Correct.
So could you tell me a little bit about that, explain to our viewers how it works, and maybe even explain how you conceived of the idea in the first place?
I'd be happy to, Trevor. We're talking about the PCD, which is the progressive cavity dispensing. And with that, we're able to focus on no dripping, no drooling, continuous volumetric dispensing, and also make sure that the viscosity, because of viscosity changes, that the volume that we're dispensing remains the same, so that as you have temperature increases or changes in viscosity, we want to make sure we're still dispensing the same amount of volume at all times.
Right.
I have an example here, the way the technology works. And the technology works with a rotor, which is the metal part in the middle. And the rotor will rotate inside the stator. And the stator has a series of cavities. And as the rotor is turning, it's moving the material through the cavities volumetrically.
Right.
And because it is a sealed environment, we're able to control the dispensing precisely to within plus minus 1.5% without any dripping or drooling.
Excellent. So you can literally make a drop of water start to appear out of the syringe and suck it back.
Absolutely. We control that through the suck back variation to be able to pull it back to, again, make sure that we control the exact amount of material. Right. It's something that an auger cannot do because an auger is an open environment. If you imagine a screw turning inside a cavity, then the material will flow out, especially if it's very low viscosity like water. Right. If you have time pressure, if you suck back with time pressure, you can introduce air into the system. If you have a jet, you can only extract material. You can't control it and suck it back in. Right.
So typically what sort of applications are you using this for, or what was it designed for?
Right. We designed it for materials from water in very low viscosity all the way up to about 65, 70,000 centipoise. So a couple of the applications, probably our largest ones, are LED dispensing for filling LEDs, for encapsulating LEDs with phosphor through syringe mixing. Another very high-end usage is the underfill application for underfilling BGA and die and semiconductor packaging. BGAs, of course, in circuit board assembly, especially when we're dealing with die or BGAs that are about 400,000 square, all the way up to very large ones. We are able to flow a large amount of material very rapidly at a controlled pace.
Right. Yeah. I mean, obviously, with the reduced geometries these days on boards, it's more important to have a higher accuracy so that you don't have too much flow out or material escaping into other parts of the board.
Correct. And with the progressive cavity technology, we can be slightly higher. We have some very unique geometry nozzles that we can use to get very close in between components. The other ability that we have is through our Ultipath software. And what Ultipath does is it allows us to take the series of BGAs on a board, let's say, all the different sizes. That is input in a file, and with that file, then the software, our flowware on our dispensers will automatically calculate the best path to keep moving and putting down the correct number of passes of material without stopping at, again, a higher flow rate than other type dispensing technology.
Okay, so the cycle time can be faster because you've got better control of the process.
Right. We can actually improve the cycle time dramatically with better control through the Ultipath software in combination with the higher flow rates from our PCD technology.
Right. Now, going back to the LED applications for a moment, I mean, the control of the phosphor onto these LED lamps is very important. Can you tell us a little bit about how it works there?
Right. One of the things that we have, Trevor, is a syringe mixer. Okay, so the syringe is typically mounted here on the valve, as you see, with the red material in this position. So we would mount this here. What that allows us to do is maintain a mixture, proper mixture of the correct amount of phosphor with the LED encapsulation material. So thereby, when we have to hit a certain percentage of phosphor for each LED, we're able to do that through the proper control of the
yeah,
mixture.
you can see it's very uniform through the different turns on the
here we're using some sparkle material just to demonstrate the philosophy.
But you can see the philosophy, you can see the uniformity there.
Absolutely, and when you're trying to hit a light box for a certain color, it's very, very important that all of your dispenses meet that.
Right.
Because the customers require it.
Okay, good. So Sven, let's talk a little bit about some of the other traditional dispensing tools and applications that GPD has been doing for many years.
Okay.
Tell me a little bit about where you originally came from and how you got into the dispensing side and some of the other key machine equipment you have.
Absolutely. GPD Global, of course, has been in the industry for many, many years. Most or a lot of customers knew us in the mid-'80s to late '90s because of our component prep equipment, forming the leads on resistors and capacitors, TO220s, that type of product. We also had our peel back force tester, which was the industry leader for tape, SMT tape, peel back force testing, and that is around. We have many customers around the world for those still today. In the mid-'90s, though, we knew we had to diversify. We knew we had to get into another industry, otherwise we would remain small. And one of the areas that we saw an opportunity in was liquid dispensing. And so we gradually phased our way into that, working with some products, and then eventually designing what we called our larger platforms, the DES series, and then looking for a higher speed, mid-level, high-end for semiconductor and for other applications such as die attach. We felt we had to have one of the best precision models available, and thereabout came our Max system.
Right, and that's a traditional needle-based dispensing system.
Correct. We do, the Max series is our system. So our idea was that we wanted to control the accuracy of the product we were dispensing. So we have traditionally used auger valve technology for that, our micro volume or MicroDot dispensing, which is a very precise auger built from carbide, and it's inserted in a carbide sleeve. We rotate it very slowly so that we're not impacting the material, we're not cold welding when we're doing that. And for solder paste below 10 mil dots, we're now as low as 5 mil dots comfortably. And conductive epoxies for die attach. This is an area where we have been extremely strong for micro volume, for microwave applications, for military applications, for certain type lead frame products in the semiconductor industry.
Right. Okay, that's very interesting. So the now you have also have these inside your own machines with XY gantries, etc. But recently you've been also selling just the dispensing system into what we would call traditionally OEM applications. Can you tell us something about this?
Yes. One of the things we did with the PCD technology, we have our own pump and we have our own controller system.
Okay.
And so we have the ability to, of course, mount it on our dispensers, as you mentioned, but one of the things that we saw a need in the industry for is a lot of customers just want to incorporate it in their own robotic systems or in their own automation.
Right.
And so we have made the decision about a year and a half ago to promote it as a standalone basis. So customers are able to purchase the pump and the controller on an independent basis and then integrate it into their own automation, or also use it on a standalone basis if they're just doing manual operations. We have been doing this primarily in the United States as we release the technology, but effective in March, we will be going worldwide with that capability.
Really, really. Yeah, well that's an obvious method of growing the company fairly quickly, because that'll open up a lot of opportunities of other people selling your displacement pump.
Exactly, and it's one of those strategies that we feel is important because we feel that if customers begin using it in this fashion, then they'll also maybe be interested later on in putting it on one of our dispensing systems if they're comfortable with the technology in their processes.
Right, right. So, last question, what's next?
What's next? We are working on some new system platforms in our R&D center, which we hope to be able to announce before the end of this year. One platform in particular, but probably the most important thing, Trevor, we have always done a good job of applications and service and support here in the United States, but we also have a lot of customers overseas.
Right.
And we're now understanding and realizing and moving forward with satellite offices. Beginning in Southeast Asia, we're opening an office in Penang, Malaysia in March. We'll be making that announcement later this month. And then we also hope to, again, duplicate that same strategy in China and potentially later this year also in Europe.
Right. Well, it sounds like you're going in the right direction, Sven, and lots of exciting things happening here at GPD. So thank you for spending some time with us today and explaining your technologies, and we wish you every success with your new office in Penang and of course later in China.
Thank you very much, Trevor.
Thank you very much.
Thank you.
Thank you. This is Trevor Galbraith reporting from the GPD booth here at APEX.